Welcome to this virtual class. Nasa week 14 tayo. Our topic is Chemical Bonding Part 1. For our learning objectives, at the end of this presentation, you'll be able to define ionic compound, define ionic bond, describe physical properties of ionic compounds, use electron dot diagrams to illustrate electron transfer and bond formation, explain how ionic compounds are named, identify properties and uses of ionic compounds, use octet rule, and define Lewis electron dot structure. Okay, so does the sea really have salt in it? So we can get common table salt from several sources. It can be mined in a solid form or found as a solid in deposits. We can also get salt from the ocean, but it really does not exist as salt when in solution. So the sodium ion and chloride ion are dissolved but not combined into structure until all the water is removed. That's dry, no? Crystalline form. Most of the rocks and minerals that make up the Earth's crust are composed of positive and negative ions held together by ionic bonding. An ionic bonding is an electrically neutral compound consisting of positive and negative ions. So you are very familiar with NaCl, yung ginagamit sa kusina. So that NaCl crystal consists of equal number of positive sodium ion and negative chloride ion. Okay, so what is an ionic bond? So oppositely charged particles attract each other. When we say oppositely charged particles, one should be positive, the other one must be negative. So this force, this attractive force, is often referred to as electrostatic force. So an ionic bond is the electrostatic force that holds ions together in an ionic compound. Okay, the strength of the ionic bond is directly dependent upon the quantity of the charges and inversely dependent on the distance between the charged particles. And if may makita kayong 2 plus and 1 plus charges, so 2 plus charge will make a stronger ionic bond than 1 plus charge. The reason? A larger ion makes a weaker ionic bond because of the greater distance between its electrons and nucleus of the oppositely charged ion. So meaning, ang 1 plus yung larger ion. So weaker ionic bond yung 1 plus. Okay, so we have here the illustration of the electron dot diagram ng Na and Cl. So alam natin that yung Na nasa group 1. And then kung balik-balikan natin yung configuration ng Na, may atomic number yung Na equal to 11. So pag i-distribute natin yan, starting sa 1s2, so yan ang first level. And then 2s2, 2p6, and add natin ito, 2 plus 2 is 4 plus 6 is 10. May isa pa, na? So sa third level, 3s1. Okay, so ito yung outer level. So meaning, yung outer level ng sodium, outer energy level ng sodium atom, merong isang electron. 1. Okay, so ilagay natin yan as dot. Isang dot. Now, for chlorine naman, Okay. So, chlorine, merong 7. So, for the configuration of chlorine, the atomic number is, I'm not sure, like 17. So, 1s2, 2s2, second level, 2p6, total of 10, 3s2, and 3p, remainder 5. So 5 plus 2, 7 plus 10, 17. So meaning, at the outer level of chlorine, merong 7 electrons. So that's why we have 7 dots around chlorine atom. Now, kinakailangan ng mga atoms na ito na merong 8 electrons. 8 electrons dapat yung nasa outer level para maging stable. So, si Na kailangan ng 7. The same time, si chlorine naman kailangan ng 1. Now, Na is a metal. So, ang tendency ng metal, sila yung taga-bigay, sila yung donor ng electron. While kung merong donor, meron ding receiver. Taga-receive, no? Si non-metal na chlorine. Non-metal. Okay. So, instead na kunin ni Na yung 7 electrons ni chlorine, ibigay na lang niya yung 1. Kasi pag kunin niya yung 7 electrons ng chlorine para maging stable, maging 8 ang outer energy level ni Na, that requires a lot of energy compared kung ibigay na lang niya ito. Now, in giving up, nakita niyo itong arrow na to, this indicates na there is transfer of electron from Na to Cl. So after na ma-transfer itong 1 electron dito, magiging Na plus yan. So ano ibig sabihin ng Na plus? Bakit plus na ngayon? Kasi pag neutral kasi yung Na, ang neutral Na equal yung number of negative and positive charges. Now, since naibigay na yung isang electron doon sa chlorine, nagsobra na yung proton. That is why we have Na plus. Excess of 1 proton na yung Na. That's why we have Na plus. And then, by accepting 1 electron from sodium, si chlorine ay magiging negatively charged. Bakit kaya negatively charged? Kasi wala pang natanggap si Cl, balance yung positive at saka negative charges. But then, due to transfer of 1 electron from Na, nagsobra na yung electron. That is why the charge now is negative. Okay? So, after sa transfer, Na now is positively charged while chlorine is negatively charged. Sa formula, this is, pag wala kang makitang 1, meaning 1 yan, no? Walang number sa taas, meaning plus 1 minus 1. And then, i-criss-cross natin yan. Yung mga superscript ng Na at saka Cl, yun din yung subscript. Now, since 1, wala kayong makitang number as subscript ng NaCl formula. Okay? So, that is the electron dot diagram ng NaCl. So the ionic bond is the attraction of the Na ion and Cl ion. So it is conventional to show the cation without dots. Ion without dots, no? Around the symbol to emphasize that the original energy level that contained the valence electron is now empty. So the anion is now shown with complete octet electrons. Okay, balik-balikan natin ito si chlorine. So, with the transfer of 1 electron from Na, naging kompleto siya 8 electrons. What happened now to Na? Kasi nawala na siya ng isang electron. Ano na pala yung next configuration? You look at the Na. Okay, so adding 2 to 6 is equal to 8. So, by giving up 1 electron, magiging stable si Na. to combine with other element. Okay. So another example is Mg and Cl. So take note that Mg belongs to group 2. So Mg, ang configuration ng Mg with atomic number equal to 12. So 1s2, 2s2, 2p, 6, and 2, 4, 6, 8, 10. Meron pang dalawa. So 3s, 2. Okay. So meaning, ang valence electron ng Mg is 2, represented by 2 dots. Itong dalawang dots na to. Now, again, to analyze Mg, kailangan niya ng 6 na electrons para maging stable. But then, since Cl yung nakapartner niya, pwede niya i-donate yung isang electron doon sa first Cl atom. And yung second electron niya, ibigay niya sa second chlorine atom. Para makompleto yung Cl28, another Cl8, and yung Mg, pag i-remove natin ito, pag i-transfer yung dalawang electrons, yung magiging 2 plus 6. Ayan. So, equal to 8, following the octet rule. So, after ma-transfer ito, nagsobra na yung proton. That's why the formula of ion, Mg ion is 2 plus, while yung chlorine, Cl negative. Now, next is to crisscross para maging formula ng compound. Then we have Mg, subscript 1, Cl2. So, kung ano ang superscript dito, yan ang subscript ng chlorine. Superscript ng Mg is the subscript of chlorine after crisscrossing. So, the name is magnesium chloride. So, what is an ionic compound? It is a compound composed of ions held together by electrostatic forces, termed ionic bonding. The compound is neutral overall. Ano ibig sabihin ng neutral overall? Pakita ninyo yung formula ng NaCl at saka yung MgCl2. Neutral overall. Wala na kayo makitang plus or minus sa formula. But then it consists of positively charged ions called cation, the Na at saka Mg, and negative ions, the Cl. No, kahit na neutral overall siya, consists of positive and negative charges pa rin. So what is an ionic bond? So it is a bond. The ionic bond is also called electrovalent bond. No? So it is a type of linkage formed from the electrostatic attraction between oppositely charged ions in a chemical compound. So such a bond forms when the valence or outermost electrons of one atom are transferred permanently to another atom. Meron tayong another type of bonding, covalent bonding. So, covalent bonding is sharing of electrons. Ito naman, electro, meaning electro, charges, no? Plus and minus. That's ionic bond. So, next. Okay. So, which cation, Na plus or Ca2 plus, superscript ito kasi charge, would form a stronger ionic bond with Cl? Na-mention natin ito kanina, no? So, the answer to that is the 2 plus charge. Si 2 plus charge will make a stronger ionic bond than cation 1 plus. Bakit? Kasi a larger ion yung 1 plus, makes a weaker ionic bond because of the greater distance between its electrons and the nucleus of the oppositely charged ion. So what are ionic compound? So ionic compound is a compound bonded with the electrostatic force. Okay, so result ng ionic bonding. No? So all compounds formed when atoms of different elements share or transfer electrons. Compounds in which electrons are transferred from one atom to another are called ionic compounds. So in this type of compound, electrons actually move between the atom rather than being shared. No? Take note of the keyword na ionic compound. Ionic bond is transfer of electron. So there is giving up or there is accepting receiver. No? Kung merong donor, merong receiver. Can you explain why calcium chloride prevents ice from forming on a snowy road? Okay, so the answer to that, if CaCl2 dissolved in water, CaCl2 dissolves in water, it breaks down into its ion Ca, 2 plus and Cl. So when water has ions, kung merong ions yung water, it has lower freezing point. And pure water freezes at 0 degrees Celsius. With calcium chloride ions dissolved in it, it won't freeze unless the temperature reaches 29 degrees Celsius or lower. So that is why CaCl2 prevents ice from forming on the snowy road. Okay, so what about the dark crystals? No? So many compounds form molecules, but ionic compounds form crystals instead. So a crystal consists of many alternating positive, take note, positive and negative ions, alternating, bonded together in a matrix. As in the figure, so as you can see, meron tayong green ball and blue. No? So alternating yung arrangement ng blue and green. Wherein yung blue, yung larger ion is chlorine and sodium ion yung blue. So the sodium and chloride ions are attracted to each other because they are oppositely charged, so they form ionic bond. And then sodium chloride crystals are cubic in shape. So when you say when it is cubic, then there are kung cubic merong 6 faces, no? That's why pakita niyo yung salt pareho nito, cube. Other ionic compounds may have crystals with different shapes. Hindi lahat na ionic compounds would form cubic crystals. So what about paano ipangalan yung mga ionic compounds? Okay. Ionic compounds are named for their positive and negative ions. First is to name the positive one, mauna, followed by name of the more electronegative ion. And for example, positive sodium ion and negative chloride ion form the compound named sodium chloride. So similarly, we have calcium and chlorine, so calcium chloride. Okay. Paano i-name itong 1 to 5? Again, i-determine niyo ang pangalan ng una. Okay. So, huwag niyo kalimutan that ionic compound is a compound between mauna si metal plus non-metal. So, to name the first element, pangalanan niyo yung anong klaseng metal. Like for example, in 1, calcium, 2, aluminum, 3, potassium, Ag is silver, 5, Mg, magnesium. Kompletong pangalan sa first element. This is binary compounds. Next is that, kunin natin yung mga part ng pangalan ng second ay ng non-metal. Like for example, for chlorine. Chlorine. Kunin lang natin yung chlor. And then, i-add natin yung IDE. Okay, so fluor sa fluorine, fluor. Sa iodine, IOD. Sa oxygen, OX. And then again, plus IDE. So, this is calcium chloride. Subscript ito. Aluminum fluoride. Potassium chloride, silver iodide, magnesium oxide. So, yun yung pangalan. Again, pangalan ng first element, kung anong metal na yan. And then, part ng name ng non-metal, and add IDE. Chlor, IDE. Ox, IDE. IOD, IDE. So, ganun. So, what is the name of the ionic compound that is composed of positive barium ion and negative iodide ions? So, alam natin na barium, and negative iodide, so barium iodide. With formula, so kung ipasulat pa sa inyo yung formula, Ba2+, charge ng barium nasa group 2 kasi ito, and then iodine nasa group 7, negative charge 1, negative 1 charge, and then crisscross. So the formula therefore is BaI2. So again, the name is barium iodide. So what about properties of ionic compound? So the crystal structure of ionic compound is strong and rigid. It takes a lot of energy to break all these ionic bonds. So as a result, ionic compounds are solids with high melting and boiling points. So take note of that. With high melting and boiling points. So you can see the melting and boiling points of several different ionic compounds in the table sa next slide. And to appreciate how high they are, we need to refer that to the melting and boiling points of water. So para ma-appreciate natin kung ano kataas yung melting at saka boiling points ng mga ionic compounds, compare natin yan sa melting and boiling points ng water. Okay, ito yung mga few ionic compounds. We have sodium chloride, NaCl, calcium chloride, CaCl2, barium oxide, BaO, iron bromide, FeBr3. So, ang melting point ng sodium, yung sodium na lang, 801 degrees Celsius. Sa water, 0 degrees Celsius. Then, sa boiling point ng water, 100. Sodium chloride is 1,413. So, as you can see, sobra kataas, no? 1,413 degrees Celsius yung boiling point ng sodium chloride. Now, take note, naka-pure ito, yung crystalline form pa. So, for iron bromide, for barium oxide, we have 1923 and 2,000 yung boiling point. Okay, so very high melting and boiling points compared to water. Now, what about the conductivity? So, solid ionic compounds are poor conductor of electricity. The strong bonds between their oppositely charged ions lock them into place in the crystals. Therefore, the charged particles cannot move freely and carry electric current, which is a flow of charge. But all that changes when ionic compounds dissolve in water. So when they dissolve, they separate into individual ions. The ions can move freely, so they can carry current. Dissolved ionic compounds are called electrolytes. So That's the conductivity of ionic compounds. So the rigid crystals of ionic compounds are brittle. They are more likely to break than bend when struck. So as a result, ionic crystals tend to shatter easily. You may try striking salt crystals with a hammer, and you'll find that they readily break into smaller pieces. Brittle. No? So ito yung mga few ionic compounds and their uses. Ionic compounds have many uses. Many ionic compounds are used in industries and even sa human body. No? So the human body needs several ions for good health. And having low levels of ions can endanger important functions such as heartbeat. And then, kailangan natin yung ions, especially pag merong mga diarrhea, no, mga vomiting, no? Kailangan natin i-replace yung mga electrolyte na yon. Solutions of ionic compounds can be used to restore the ions. Okay, so few examples ng mga ionic crystals. Crystal of silicon. We have crystals of mercury. And then copper, itong blue. And then we have ore of vanadium. Okay, so what produces colored crystals? The figure in the previous slide shows just a few examples of a color and brilliance of naturally occurring ionic crystals. The regular and orderly arrangement of ions in crystal lattice is responsible for the various shapes of these crystals, while transition metal ion give rise to the colors. Okay, so for the physical properties of ionic compounds, yung melting point, as we have discussed no, in the previous slides, the melting points of ionic compounds compared to water is very high, similar to the boiling point din. So mataas din yung boiling points ng mga ionic compounds, or boiling point ng ionic compounds compared to water. Ionic compounds are generally hard but brittle. Why? It takes a large amount of mechanical force, such as striking a crystal with a hammer, to force one layer of ions to shift relative to its neighbor. However, when that happens, it brings ions of the same charge next to each other. So, the repulsive forces between like-charged ions cause the crystals to shatter. So when an ionic crystal breaks, it tends to do so along smooth planes because of the regular arrangement of ions. Okay, so yan ang sodium crystal in 2 dimensions, and then Cb struck by a hammer. So for the conductivity of ionic compound, as we have discussed, pag pure, for example, yung NaCl pure, crystals, walang, considering dry ito ha, yung asin na makita natin sa kusina is a non-conductor, poor conductor of electricity. Okay, but then pag i-dissolve natin yung NaCl with water, so magiging NaCl solution, maging strong electrolyte ito and will conduct electricity. Pag pure, it is a poor conductor of electricity, but then pag ma-dissolve with water, maging electrolyte ito. So how are electrons organized in atoms? Ito yung para sa octet rule. Okay, so noble gases are unreactive because of their electron configuration. Noble gas na yon has electron configuration of 1s2, 2s2, 2p6. Kasi yung Ne, atomic number is 10. That is why pag i-distribute natin yan, 1s2, 2s2, and 2p6. So, fully outer shell and cannot incorporate any more electrons into the valence shell. That is why we can say that neon is unreactive. Less likely to form a compound, less likely to react, less likely to combine with other elements. So, pare-pareho yan sa mga other member ng noble gases na merong configuration na 2 plus 6 is 8. That's why na-belong ito sa group 8 na periodic table. Except, of course, helium. Kasi sa helium, meron siyang configuration na 1s2. But then, at 1s2, stable na rin sa helium, like other noble gases. Okay, so what is octet rule pala? So octet rule states that atoms tend to form compounds in ways that give them 8 valence electrons and thus electron configuration of a noble gas. But then, merong exceptions, helium at saka lithium. Because Li, Z of Li is 3, so 1s2, following the configuration of helium. And meron pang isa, 2s1. So once na ma-transfer ito, because lithium is a metal, so electron donor, isa ito sa mga electron donor, so ma-transfer itong 1. So the configuration of Li follows the configuration of helium. That is why exempted sila sa octet rule. Okay, so configuration of neon. So neon has atomic number of 10. So, pag configuration natin yan, electron configuration 1s2, 2s2, and 2p6. So, as you can see, kompleto yung 8. Okay. So, there are two ways in which atoms can satisfy the octet rule or can follow octet rule. First is by sharing of their valence electrons with other atoms. So, para maging 8, pwedeng mag-sharing. Para maging 2, mag-sharing. Like hydrogen, no? Hydrogen has 1 electron, so kailangan niya ng other hydrogen atom para maging H2. Stable, para maka-combine with other elements. And then the second one is by transferring of electrons. So this is covalent bond. The other one is ionic. So atoms of metals tend to lose all of their valence electrons, while atoms of nonmetals tend to gain electrons in order to fill their outermost principal energy level with 8 electrons. So what is the electron configuration of a noble gas? Okay, so the following are the members of the noble gases, or group 8 or group 0 in the periodic table, starting from helium, neon, argon, krypton, xenon, and radon. So again, ang configuration ng helium is 1s2. But then pagdating ng neon, we have 2s2. Last configuration ito ha, yung sa outer level. And then 2p6. Ito namang argon, 3s2, 3p6. Si krypton naman 4s2, 4p6, 5s2, 5p6, 6s2, 6p6. So magkapare-pareho yung 8 electrons on the outer shell of the noble gases. Okay, so is electron configuration important? Of course, yes, no? So the electronic configuration of an atom determines the chemical reactions the atom can participate in and determines the kinds of molecules that atoms can combine into to form more complicated substances. How do metals change to obey the octet rule? Of course, na-mention na natin ito kanina. Atoms of metals tend to lose all their valence electrons, which leaves them with an octet rule from the next lowest principal energy level. So by giving electrons on the outer level of metals, magiging stable sila sa uh, next na lowest energy level. Okay, so nasa number 4 na tayo. How do non-metals change to obey the octet rule? Okay. So atoms of nonmetals tend to gain electrons, while metals tend to lose electrons. Ang mga nonmetals naman would gain electrons in order to fill the outermost principal energy level with an octet. So atoms form compounds in ways that give them 8 valence electrons. Metals tend to lose to achieve this configuration. Nonmetals tend to gain electrons to achieve this configuration, this octet rule, or rule of 8. Okay, next is the Lewis electron dot. So kung makita niyo yung hydrogen dot, that's the Lewis electron dot. So kung hydrogen, the atomic number of hydrogen is 1. That's why yung configuration na is 1s2. Okay, 1s1, sorry. 1 electron lang pala. So ang electron dot niyan is H dot. So itong dot na to represents 1 electron on the outer level of hydrogen. Now, since kailangan ng hydrogen by 2s para maka-react with other elements, so kailangan niya would follow the configuration of helium. So need another hydrogen atom. So that's why we have 2 dots. And then, i-connect natin ito as dash. So pag check natin how many electrons yung first hydrogen atom, 2 is 2, no? Para sa first hydrogen. Second hydrogen naman, it is 2 by sharing of electrons. So pwede na naka-dash ang pagsulat, pwede naka-dots. So a structural formula is a formula that shows the arrangement of atoms in a molecule and represents covalent bonds between atoms by dashes. So kung makita niyo yung mga organic compounds like proteins, carbohydrates na naka-dash yung gamit doon sa structural formula ng compound. So, what about octet rule and covalent bonds? No? So they conform, when ions form, they conform to the octet rule by either losing or gaining of electrons in order to achieve the electron configuration of the nearest noble gas. Okay, so for hydrogen, as I have said a while ago, na ma-attain niya yung configuration ng helium by sharing electrons. Okay, ito yung example. One hydrogen atom, and then pwede na by gamitin yung dots, pwede yung dash. So this is H2 molecule. So for our lesson summary, an ionic bond is electrostatic in nature. Ionic compounds consist of oppositely charged ions that are held together by ionic bonding. The opposite charges cancel out, so ionic compounds have a net neutral charge and would form when metals transfer valence electrons to nonmetals. And ionic compounds exist as crystals rather than molecules. A crystal consists of many alternating positive and negative ions bonded together in a matrix. And to name an ionic compound is to name the first metal. To name is to identify kung anong klaseng metal yun, kompleto yung pangalan, followed by part of the non-metal, part of the name of the non-metal, and then add IDE. For ionic compounds naman, solid ito with high melting and boiling points compared to the melting and boiling points of water. And they are good conductors of electricity pag ma-dissolve in water. And the crystals are rigid and brittle. Maraming uses ang ionic compounds, especially in industries, and of course, in the human body and other living organisms. Electron dot diagrams can be used to illustrate electron movements and ion formation. Atoms form compounds in ways that give them 8 valence electrons, yung octet rule. And metals tend to lose electron to achieve this configuration, while non-metals tend to gain electrons. Lewis electron dot structures show the bonding in covalent molecules. And covalent bonds between atoms can be indicated either with a dots or a dash or dashes. Okay, so that's all for today.